announcement real quick, just because people in the last webinar asked. Raleigh and Neil are not doing their presentation tomorrow. They're doing it Friday, so look on your calendars for that. I actually sent out an email about that. And if you haven't already, get into the Eat Your Dirt seminar next week, summit all week long. It's free. If you want to fly out to California and come to the workshop that Mark's doing this weekend, I'm sure you could do that. Let's see, that's it. So go for it, Mark. It's all yours.
All right, welcome everybody. Glad to see you here. I'm a little bit subdued tonight, not because of the weather, but because I went a solid week that finished with you know, 2 full days at a conference in Ontario and then a solid day consultation on Monday. Flew back yesterday, got to sleep in my own bed, and I'm leaving at like 4 o'clock in the morning tomorrow. So come to California. I'll be a lot more rested by then. Anyways, we're going to finish tonight, or finish the structure and growth of woody plant stems tonight. We'll do a little bit on root structures next week. And I don't know if you guys have realized yet how I kind of structured the whole layout of this whole course was from the big picture from the landscape scale, ecological systems, and now we're dialing it down smaller and smaller to the structure and growth of the plants. We'll get on the last slide of this thing tonight. I'll show you what we've got left to cover before we're finished with this whole module. So we might as well just jump right in here. And let's advance for me, please, guys. There we go. We've been dealing with regeneration ecology, and the big question is what causes a natural plant community to regenerate, persist, propagate, and move through time and through space. And then how can we use our knowledge of how plant communities regenerate themselves? How can we use that knowledge to guide our decisions? Because if we understand how these plant communities operate, how they establish, how they grow, how they start to thin themselves out, how they now regenerate and carry forward in the future, we can tell specific times when we can interact with that system in order to accomplish our objectives. And so that's part of what we're doing with this whole section here. And remember that it's the ecological, biological sciences have used the term regeneration to mean how plants maintain their cells, their populations, and the different assemblies of populations, the community of populations. They maintain themselves as an ecological entity throughout time by the process of regeneration. The reproduction, dispersal of the propagules, germination, establishment, and there are different kinds of disturbances. There's gap disturbances like lightning strikes, a little minor blowdown, a dead tree falls over, broad scale disturbances like fire, browsing, landslide, volcanoes. Someone posted, Ben Eldridge, I believe it was, he's part of our EAT community here. He posted on Facebook the other day this hillside in Russia where the permafrost has melted and the whole entire mountainside is just slowly moving downhill like a slow motion ice and mud and tree tsunami as it's crossing the highways. Those are all disturbances, and it's the type of disturbance that, and then the disturbance adaptations of the plants that are in there that affect whether that plant community can propagate, can regenerate or not. There's the initial site establishment, followed by stem exclusion, this phase right in here. We've got our understory initiation. This is a gap phase disturbance where a single double tree blows down. And then this now will be the next generation of trees that replace this overstory when this overstory finally comes down. This is the logical, methodical sequence of ecosystem development. And remember that if a plant and animal community cannot reproduce itself and persist in the environment, by definition, it's not regenerative. This is just a little bit of a, we have to redefine the definition for the marketing folks who've captured the word regenerative and using it for agriculture, because ecologically, regenerative means its ability to persist and reproduce and continue through time in an environment. This right here is regenerative agriculture. Why? this whole system that consists of chestnuts and hazels and walnuts and grasses and animals and grapes and pears and plums and Italian pines and a whole host of other species has been alive, reproducing itself at least in historical record for at least 1,200 years. And for the past 80 years, it's been doing so without any human intervention at all. The species are all there. All of the food is all there that you could possibly get from this natural system. It's a regenerative agricultural system. What about this? Do a Google search for regenerative farm images. Does this farm meet the ecological criteria of regenerative? I would argue that if the true test of a regenerative system would be to go ahead and hit it with a disturbance. Let's go give this a natural disturbance. This happens to be in California. Let's hit it with a natural disturbance that's common in California. Whoosh, there we go. Okay, what happens to that farm? Oops, that's not a regenerative farm. It just isn't. Doesn't meet the criteria, ecological criteria for regenerative. And I'm not saying that that kind of farm is bad. I'm just saying that we need to have a conversation about this word, this term, regenerative farming. What does it really mean, and whose term of regenerative are we using? I'm an ecologist. I study nature. I'm going with that definition right there. All right, so we're talking about our plants. Seedlings grow into mature woody plants. It's a pretty complex process, but there's two specific types of growth, distinctive. One is the extension of the growing points that forms the shoots and a crown. And if my finger here, if you guys got me on the webcam, if my finger is a woody plant, trees that we're familiar with grow from the tip. So the top grows up and it lengthens that way. Grasses grow from the base and they push themselves up. So the stem on grass is growing from the bottom, and the stem on a tree is growing from the top. There's two different kinds of growth, primary growth and secondary growth. Primary growth is that elongation. That first shoot goes up. Zip, it's the elongation of that stem. Secondary growth is the fattening of the stem. So here's this first stem right here, primary growth. This line that you see, the vertical line, will double in fatness. That's secondary growth. Well, then it sends out side shoots. That's primary growth again, in a terminal shoot. And it will continue that process. The lengthening of new stems is the primary growth. The fattening of existing stems is the secondary growth. Now, the combination of these growth processes, they all follow a certain architectural pattern for each different species of tree. You can tell a number of different things by the shape of these trees. You can tell what species it is. You can tell what kind of disturbances affected it. You can tell whether that tree was a far northern tree, a high altitude tree. You can tell whether it was grown in close proximity to other trees or all by itself out in the open. And every tree that grows all by itself out in the open with optimal conditions will have a very specific stylized shape, and it can be useful for identifying trees. And of course, growth and height and mass, we've seen this slide a number of different times. It requires specific requirements of space, light, nutrients, and moisture. Now think about that. We can use the space that each plant has. We can manipulate that by adding more trees to the space, so we're taking more space up with trees, or by removing trees from that, either by digging them or cutting them with a saw. Light, we can modify the light. Once again, that's a function, often a function of density. We can also put shade cloth up if you want to do that. The nutrients, fertilizers, are a tool that we can use, and moisture, water or lack thereof, is what we can use. These are all four little adjustment knobs to keep our system going. So those, we're going to understand the regeneration process in order to manage our system. We're going to understand how to manage space, light, nutrients, moisture, and then the other one is that these basic requirements of space, light, nutrients, and moisture may not be good for some certain species or for individuals unfit individuals within that species. So now we're talking genetics. So our main control points, of course, are where we can interject and manage our system, our understanding the reproductive life cycle, our regenerative pathways, space, light, nutrients, moisture, and genetics. And then, of course, we use disturbance as the way to twist those 6 different knob adjustments. So the growth habit and the form is influenced by the apex, the apical control, the apical meristem, the bud at the top. It has all kinds of chemical controls going on that determine how fast the lateral branches goes, which directions they'll go in, how fast its own cells reproduce, and so on. All of these things influence the tree architecture. So as you see, it's simple, right? It's complex, but it's not complicated. Very simple rules. Now, I hope some of you guys are looking at these various different tree silhouettes and identifying the types of trees that I'm looking at. Pretty fun. I'm getting a feedback. Is that from you, Wayne? Right, Pete. So in northern and alpine environments. Okay. Oh, I wonder if that's me. I had to mute my computer, right? That's probably what it is, because I'm on my phone.
Yeah, you should mute your it's your computer, because you're coming in really clear to all of us. So.
But I'm getting all right, I don't even see a mute button on mine anymore. Anyways, I'll just keep going. Especially northern and high alpine environments, trees that have a classic, typical upright conical form, the apical meristem, the terminal bud, has real strong hormonal control, and the terminal shoot, called the leader, sometimes grows, well, sometimes it does. It grows much faster than the lateral shoot. And I'm going to do this, see if this works. Maybe that'll work. Because I'm still getting the double feedback here really bad. Triple, quadruple, double feedback.
Yeah, we're not hearing it. We're not hearing it here. You're fine.
If you guys aren't hearing it, I'll just keep going. All right. So that's called the X-current tree form. Classic, typical. This is up in Alaska. This is somewhere in Colorado. That's on New Forest Farm in Wisconsin. That's mostly species determined. The environment will impact that a little bit more as well, as we'll see later on. And in trees where the lateral branches grow just as fast or nearly as fast as the terminal leader, they'll end up being a lot rounder. The main stem forks repeatedly instead of being a single tree with branches coming off of it. It typically will spread. That's when I was in college. It was the deliquescent form, which is also called the decurrent form. Yes.
Mark, they are saying they're hearing the echo. Maybe we can. They are saying that they're hearing the echo. Is there any way you could just mute your computer? Or?
Well, isn't there supposed to be a mute button on my dashboard, on my control panel? I don't see it anymore. I see the thing that controls. Now my camera's off. What's that? What did that do?
No, you're not, because that turned your screen off.
Okay.
That you turned the screen off there. There is, because you're on your phone, it actually won't show up. No, I've been muting myself, Fernando, so I'll mute myself more to see.
All right, we'll see what happens. All right, the X-current forms and deliquescent forms. The angle of incident light has a strong effect on the tree form as well. Now, the one on the left is typical of far northern latitudes. Now, if you think about that, I'll use this cursor. Hopefully, you guys, I won't move it so fast. In the northern latitudes, up at the North Pole, North Arctic, down in South America as well, Southern Hemisphere, the sun is a real low angle of light. So this low angle of light affects the branches and the whole shape of the tree, and that's actually an optimal shape for capturing low angle light. Whereas this tree on the right, around the equator, they typically have these big, huge, wide umbrella shapes because, of course, on the equator, the sun is directly overhead. So that's an optimal way to capture the light. if you take more northern tree species and you move them further south, they will be somewhat squatter and rounder, but they never quite get as round as this. And if you take one of these equatorial plants and you move it up to the northern latitudes, it'll just plain die. some of the northern latitudes planes will die down in the equator as well. And now a lot of that shape that's light affected has to do with what's called phototropism, which there are hormones that are affected by the sunlight in the plant. And right now I can't quite remember what they were. I think they were auxins. Help me if somebody remembers that. I'm going from memory on that. That's what causes those plants, those little house plants on the left, to lean. And then if you look at this picture that we've seen here multiple different times, 20 years ago, this was all young brush. Didn't look very much different than the part on the right-hand side of the little roadway. There was brush on the right side of the road, brush on the left side of the road. On the left side of the road, I managed that by changing the space available for the individual trees. I was removing trees quite fast, at the tune of at least 1 cord per acre, 128 cubic feet of chopped up firewood per acre. And there was more space for the trees to grow, more light for the trees to utilize, more water and nutrients available per individual. Well, also what you see is these trees here on the edge leaned out over the road to get the extra light, because each little branch composed of these little green leaves would be affected by the light. The hormones would cause it to grow towards the light. What's interesting about that is some trees will lean like that. These are purely light-reaching trees right here that lean. There was a whole chart in the table I saw when I was researching, prepping for this particular presentation, and that certain trees just don't do that. Ash trees were one of the ones that lean the least, white ash and whatnot. And then I started walking around the farm going like, oh, wow, check that out. They really don't. And some of the ones that I've observed on the farm that lean the most, these are 2 examples right here, are this is a black cherry, Prunus serotina, and this is a smooth bark hickory, one of the bitternut hickories. Those seem to be the 2 that lean the most on my farm. Some of the ones that don't seem to lean for the light were the later successional trees, the sugar maples, the beech, and the basswood. And phototropism helps those guys, though, is because they find the canopy by sending out branches every which way. And we've seen this picture before here where this basswood tree would just penetrate right through and find like a little gap and another little gap year after year as it keeps growing through this other tree until it finally grew completely through this eastern red cedar and shaded it out. And it's the phototropism causing those branches to grow outward that way to shade out the tree underneath it. Please pardon my sense of humor today, but there's some things that, you go through this. I don't really see any reason why somebody has to come up with and memorize. There was a whole bunch of different tree pattern models that I had to memorize the names of when I was in college, and I just thought it was the most ridiculous thing in the world. Why do I have to learn what a Leeuwenberg's model is, and a Rose model, and Massart's model, and so on? But all these different patterns that woody plants tend to grow in have names, and if you memorize them, you can go ahead and impress somebody. What is good, though, it is good to know what these basic tree shapes are of the basic species that are around you, because then you'll know how they'll behave. You'll know how they behave when you prune them. You'll know how they behave when they have a gap and there is light that they need to reach for. It can be helpful that way. But memorizing the names I thought was pretty ridiculous. Now, the types of shoots that a tree has and the patterns of shoot growth, they're important. And because they help that plant with its competitive ability, and there's basically 2 types of shoots on a plant. And it's ridiculous, these amazingly complex scientific names they came up with: long shoots and short shoots. And this little diagram over here shows the difference between the 2. As you got these long shoots, this primary growth, And then these are short shoots. They're also primary growth, but they just didn't, you know, bug out and really elongate like these did. And all trees have long shoots, and some have both. Some have a lot more longs than short. Some will respond to injury, like this one right here, by setting up a lot of long shoots. This is an apple tree on the right. If we're going to be growing year after year, we have 1 year's growth here. The terminal bud at the end, we'll see that in the next slide. The terminal bud sits on the end of this branch. There's a complete line around that branch right now. The next year, when that terminal bud begins to elongate, there'll be a clear and distinct ring. This goes completely around that tree. So you don't have to cut down even a deciduous tree, for example, in order to find out how old it is. If you're really able to look at these different rings, these annual growth rings, it'll be around here, one's around there, one's around there, one's around here. And now we'll talk a little bit about the terminal bud. Also can be called the apical bud. All of the different branches will also have a terminal bud on the end of it. Buds on the side of the branch are called the lateral buds. Just below the lateral bud is this little pattern where the leaf used to be attached. The petiole, the leaf stem, used to attach right there, and then the leaf would have been out on the left. In the fall, there's a layer of cells between the hard woody stem and the leaf stem, the petiole. It's like, I think it's 4 cells thick. That all of a sudden they form what's called an abscission layer, and they just kind of shut each other off, and once they're completely sealed off, they just fall away and the leaf falls off the tree. These little dots that you see on that bud scar, or the leaf scar, excuse me, is what that plant is. And what these are where the tubes came up through the stem and then came out into the leaf, and that the pattern that those bundle scars make is a thumbprint, a fingerprint of those trees. The space between nodes, the node is specifically in here where, if we're looking at the stem, there's tubes that come up here and then they bend out to go to the leaf. Well, and there's other ones that go straight up. At the junction between the ones that bend out and go up, that junction is the node, and it's right there where you'll see where the leaf attaches. Then a bud forms just on the uphill side of the leaf, right in the, so the leaf is sitting here, the bud sits right in there. That's the node, and then this is the internode between the different nodes. The pith is the little soft stuff in the middle of the stem. We won't bother to get any more detailed than this. Let's see, what else did I mention? Oh, the bud scales. The buds that you see, the dormant buds on a tree, they're covered with what are called bud scales. And these dots on the stem, sometimes they'll be vertical dots, sometimes they'll be horizontal dots, sometimes they'll be really big. They're actually holes that go all the way through to the stem that allow gases to exchange between the wood deeper in the stem and further out on the surface. Some of the lenticels seem to disappear earlier in a tree's life. Some, like on the birches or cherries, you can see, long into their life. Some cherry trees, big cherry trees, 2-foot diameter, so you can still see their lenticels on the stem. Some of the annual growth of the long shoots, cottonwood species, for example. This is populus. This is a hybrid poplar. They'll exceed 3 meters in length. So this is one of the faster growing trees. It's amazingly fast growing long shoots. That actually does say, 95, 96 inches, so 8 foot, 7 foot, 8 foot. I've even had a chestnut shoot that was 11 feet long. And I went walking through the snow today. It was quite a blustery day. I went to go find that particular chestnut tree. Do you think I could find it? And I know where everything is. They don't move anywhere. I should be able to find it, but I couldn't find it. And so I didn't take a picture of it. But I've noticed is that with the hybrid chestnuts, the one that show more of their American genetics are they just really, really elongate. And when that 11-foot stem happened was when I accidentally ran over that. It was probably a 5 or 6 year old tree. I accidentally ran over the tree with the tractor, and it broke the stem, and so I cut it off. It ended up coppicing it, and it just responded to coppicing with like 5 or 6 stems, and one of them was 11 feet long. So the super elongation sometimes can be a response to injury, or like in the case of the hybrid poplars, hybrid willows, they just run. Now, short shoots show little elongation in the internode, in between the different leaves. They're sometimes called dwarf shoots or spur shoots, especially in apples and pears. They're called fruit spurs. This is a fruit spur on apple, and you can just see how it's got these complete annual rings from the stem only elongated quarter of an inch, a quarter of an inch, a quarter of an inch. Very short elongation, whereas the long shoots will go much longer on that. Very characteristic of the Malus species apples. Also in the evergreens, short shoots are typical of like larch and ginkgo, and in the pines, there's like a little, like a mini short stem is what it is. It's a short shoot with a little bundle. It's a papery type material that holds the needles. Those are called fascicles. Those are actually short shoots, and you can see some here over on this tree. You can see this is 1 year's growth, another year's growth, another, and this is on a Korean pine back at my farm. You can kind of see 1, 2, and then this is the end where the needles are all held in a bundle. Short shoots, like fruit buds on apple trees, blueberries I showed a couple of weeks ago, they only have early leaves, and they're pre-formed in the dormant buds. They also might have flowers, cones, or thorns that are already there on this year's bud. So if you look at blueberries from a few weeks ago, there's like these little tiny buds, little triangular ones on the side of the stem, then all of a sudden there's a big round one on the end, or a couple of big round ones next to each other, or like this one previously on the apples right here. Inside that bud right there is already formed all of the leaves that are going to come out on that, and all of the flowers that are going to come out that. So what happens with that is what one of the problems is with early warm winters like we're having right now. If it's above 40 degrees Fahrenheit for too long, the meristem inside of the bud, that fruit bud on the fruit trees, is going to start to differentiate too much and will become a lot more tender, juicy, and susceptible to frost. So that if we could have a perfectly normal frost, and yet it'll kill all of the fruit buds and flowers that are in there for this particular year. Now there are seasonally determinate shoots that only go, they elongate for a certain period of time, and that's it. They only go a certain period of time. Then indeterminate long shoots just keep going and going and going and going and going and going. They're more common in the faster growing species like birch, cherry, cottonwood, sassafras, sycamore. This is chestnut stem. Of course, periodic growth rather than continuous growth is a rule among woody plants. Even plants like palms and mangroves that are thought to be growing continuously, they actually pulse. And obviously for us in the northern hemisphere with the deciduous trees, we'll have growth in the summertime. They set buds, they go dormant, they lose their leaves. That's the same in other environments in the temperate zones as well. The environmental conditions are primary drivers of this. Good luck growing when it's 40 below 0 Fahrenheit or Celsius. Light has a little bit to do with it as far as initiating growth. It's mostly the temperature that initiates growth and stops the growth. In the high northern latitudes and southern latitudes, light has a lot to do with when it starts to set buds in order to shut down for fall. But it's usually the temperature that gets it to wake up in the springtime. And notice the big straight and tall angle here for that low angle sun coming in. They can capture that low angle sun. Soil water stress typically is what causes leaf drop in tropical areas. And there are some trees that exhibit a reverse morphology, and they lose their leaves in the rainy season. This is a Phyterbia albida, which actually has been really jumped on lately by agroforesters, especially in Africa and India, in the fact that during the rainy season, when you want to have your crops exposed to the full sun, the Phyderbia drops its leaves, so you can get full sun down on your crop fields. Well, then in the dry season is when it leaves out, and then it totally covers your crop fields with leaf cover. So now your crop fields are in the shade; they don't lose as much water, and it happens to be nitrogen-fixing acacia. So you're getting the fertilizer benefit of the nitrogen-fixing nodules as you do root pruning, plus the foliage for feeding livestock. In the rainy season, you got plenty of green foliage to feed livestock, whether it's grass or forage from trees. But in the dry season, you need some green, and the Phyderbia has green for you. Actually, they're all through Africa. They've been doing experiments. The International Center for Agroforestry has been doing field trials with agroforestry alley cropping system that uses Phyderbia, and another one, Gliricidia. I forgot the species name. They're both acacias. They do the Phyderbia on either side of an alley, and then the row crop in the alley, and they'll have the Gliricidia in between every single row. So if you've got 10 rows of maize, for example, you have 10 rows of Gliricidia in there. You grow your maize crop. It grows at about the same pace as maize, and then in the fall or whatever time of the season is when your corn is ready to pick, you go through, you harvest the maize, and you harvest the Gliricidia, cut it right to the ground, and then it'll wait until the next time when you plant your maize. It waits for the beginning of the next wet period before it shoots up again. So the continuous flush forever. These little tiny thumb-sized sticks, which are great for using for cooking or for making charcoal. And with a Phyderbia and Gliricidia alley cropping agroforestry system, they're getting equal yields of maize as you would if you're using chemical fertilizers, and you get the benefit of firewood, charcoal, free fertilizer from the roots, and animal forage from the Phyderbia trees. Really useful plant. It was, whoever discovered that was really putting their thinking cap on. So there's different types of long shoot extension. There's a single flush where the long shoot grows, and then it forms a resting bud on the apex, on the terminal end of it. Well, then it also forms all these side buds ready to go. This is very common. This is a balsam fir, and so in the spring, this was young and tender, and it shot straight up, and this starts to set buds around July. So the end of July, it forms that terminal bud, and all kinds of little side buds along the way. Well, a year ago, this shoot would have shot up. This was the terminal shoot, and it would have shot up and set little terminal buds. Then the second year, it sends out all these side branches and so on. So it's every year it'll send out more side branches. So that's one kind of long shoot extension. Another one is that the long shoot will grow and then stop, form a terminal bud, and then grow again, form a terminal bud and grow again. And you think I'd be able to find an image for this? I can't anywhere. I looked and I looked and I looked and I looked. So that's a second type of long shoot extension. A third is a flush of growth followed by shoot tip abortion. So the apical terminal bud it'll keep growing and growing and growing, and it'll just lose the top of the shoot altogether. Next season, the long shoot growth will begin again at that last fully formed bud. So obviously I'm holding this upside down. But on chestnut, I see this a lot on chestnut. I see a lot on black walnut. Is this shoot will just grow like crazy. There's my cursor. Grows like crazy, grows like crazy, grows like crazy. And during the course of the season, these side buds are forming. The side buds are forming. Then all of a sudden, it gets too cold and it freezes the tip off. And then it leaves that behind. And according to science, the ecological significance of this seems unclear, but it seems pretty darn obvious to me. If you got a growth pattern that allows you to grow and just keep growing all summer long, all into the fall, and you're setting buds all along the way, if it's a long autumn, nice long weather, say in Wisconsin, we've sometimes had good long falls all the way up till November. It's growing September, October, November, when all these other trees have already shut down. It can get to canopy dominance much faster by continuing to grow that way. Then it just loses the top couple of 3 inches when the frosts really do come and shut it down, and then it just starts growing to the next bud. Seems to me that it's an amazing way to grow faster for a longer period of time than all the other trees in the canopy. Well, then if it's a quick season, say there's an early frost, our earliest killing frost in the fall was August 26th. That was in 1995. This tree would have grown up, has a couple of side shoots, and boom, killing frost. Well, what happened to a lot of different trees, like a lot of fruit trees that year, mulberries, I know that happened to a lot of black cherries that year, is their whole entire one season's growth died because it wasn't fully firmed up and it wasn't hardened off yet. The buds were completely set and the whole entire stem went. Whereas things like chestnut, it just dropped the tippity top of it. It just didn't grow that long that year. It seems like an advantage to me in regions that have the potential for real rapid cold weather onset or a protracted warm spell and the variability between it. It seems to me like a pretty good survival strategy. These are chestnuts, once again, that they just keep going. They just keep going and going and going. They are already losing the bottom leaves, already losing all their bottom leaves, and yet the top ones are still going. That shoot's still going. Look at all the other trees in this picture on the right here. They've already lost the leaves. Fall has already happened, but this was taken last fall. And the chestnuts just kept growing, And sweet gum will do that, cotton will do it, tulip poplar. Apples will do that to a certain extent, but usually not on older wood. I've only seen that really a lot on the younger wood, that it just keeps going. Now, Solepsis and Prosolepsis identify 2 types of lateral long shoot growth. Now, if we had that Christmas tree, balsam fir, that I had showed the picture of, that terminal long shoot grew, well, then the laterals grew from that stem. There are other trees that as the terminal stem grows, the laterals come out as well. Solepsis is when the laterals come out at the same time as the terminal extends. And those of you who have ever grown an avocado have seen that before. This is an avocado here on the left. And as the terminal shoot elongates, the side shoots go out at the same time. And that's solepsis. The prosoleptic growth is like on the balsam fir, where the top grows up, stops, sets buds. The next year, the side buds grow. The hazelnut's a classic example of that prosoleptic growth. There is the fact that underneath my arm here, you can see this was a long shoot. Actually, this one was 2 years ago. That was 1 year ago. That was this season. Hazelnuts will send up a single stem, really fast, elongated growth. Well, then it's on these side shoots that it'll be all set up for next year. Well, then as the side shoot grows, then it'll have the flowers. It'll set fruit, and then its side shoots will grow the next year. So it's lateral elongation of the long shoots. Then the laterals go next year. Prosolepsis. Some temperate trees, there's a second burst of growth that occurs in that same year. And I know I have some really gorgeous pictures of chestnuts doing this on my farm. I could not find one anywhere. But it'll grow and it'll kind of set buds, and it's like should be finished for the season, but then all of a sudden, for some reason, it shoots up again. And this is an oak doing that. That's called lammas growth. And I just couldn't help but getting a little bit hilarious when I started looking at that. I talked about llama, and it reminded me of the fact that once upon a time, I used to farm for the Dalai Lama. Lama, ding dong. So as Bill Murray, let's go to my farm now. Let's take a look at some of these things and actually go to a section where I've actually been working on the past couple of months now, just poking away at it, not making a big project out of it. Here's the picture. You've seen this 1,000 different times, of course. Once upon a time, it all looked like this. We're about to go to a field. I'm going to show a bunch of different fields. The first one, I think, is a view of this. The second is a view of this, and then the third is a view off of this. But check out what I found today. This is New Forest Farm 1996, I believe. This is the South Market Garden Ridge. And I think this, you can see a little bit of the scar where I started to lay out the swales on that ridge. There's one there you can see, one there that you can see. And that's this ridge right here. There. Oop, too far back. 1996. This is the mostly chestnuts. It's the chestnut, hazelnut, elderberry, raspberry, mulberry, grape polyculture. That's primarily where we feed the pigs. Those are the oldest hybrid chestnuts on the farm. This area here, you've seen it several different times. It's the area with phenomenal grass growing underneath and black walnut as the main crop tree. And that's where the picture, if you remember it, with the belted galloways underneath the black walnut trees and a mulberry tree in there as well. That was that section right there. This foreground here is mostly an apple polyculture, and then where the picture was taken from, I'm standing in what was abandoned cropland where we got it. So it would have been abandoned cropland in '95. So the '96, it was plenty of weeds. So then by '96 or '97 is when this picture was taken. Look at this triangle right here. That's a significant triangle. And then this patch of, I believe that's a winter wheat, would have been planted last fall. So this is probably late June into July where this wheat patch is. The wheat patch was right where these trees are here and went all the way around the North Ridge that way. That little triangle is this little triangle right here. That's me on a tractor, a farm all in. So that's that triangle. This was planted with Christmas trees. First of all, Scotch pine, then balsam fir, and then Korean pine up there. This area right here is now the high density chestnut planting, both here and here. And so the place where I'm going to take you, where I'm doing some work, is this area, this whole area right in through here. And it's right down at the base of this photograph right here, right in there. And this was actually a video, and I think I'm going to have to do this, undo my phone. If you can hear me on the phone, if you guys can't hear me, let me know right away when I play this video. Here we go. Let's give it a try.
It's a warm January afternoon here at New Forest Farm, and I'm up on the North Ridge. I have not yet learned how to use my selfie stick, which I got for Christmas, and apologize if those of you would like to see my beautiful face in the picture. I'm looking northwestish here. We see in the foreground those dark trees are overgrown Christmas trees that Daniel planted when he was 6. Just to the left, the tallest trees that we see along the ridge line here are chestnuts. We call those the North Ridge chestnuts. It's the first real high density block that we did.
So the North Ridge chestnuts are planted where that field of wheat is that you saw in the previous picture.
This section here in the foreground we call the polyculture because we go 4 rows of hazels, a polyculture row of chestnuts, which includes a whole bunch of other things, 4 rows of hazels and chestnuts. Then where we see the tractor parked, there's a road just starting vehicle access. It's not a real road. Between the real steep part to the left where the bluff really drops off, the flatter ground up here.
And in the, oops, I didn't mean to move forward, but in the foreground of that picture, if I can find it right in the foreground there, where the cursor is, you notice this little ring of trees here? This is one of my Winnie the Pooh houses. This one's made out of black walnut, and as the walnuts grow taller, I'll graft them together, and they'll be hollow in the middle. Big, gigantic 20-foot diameter black walnut, but I'll continue with the video. Oh, you bum, go back. I'm learning.
bluff really drops off, the flatter ground up here. When we got to the farm in '95, the flattest ground up there where the chestnuts are was corn stubble, abandoned crop fields, and then the middle sections here were used for hay, and then the steeper parts off to the left was used for grazing. One of the first things we did is we laid out the water management system, and then this road was derived from the original key point, which is 2 ridges over, and then this road goes along the edge of the bluff before it gets really steep to the left. This primary valley we see here in the shadow, this is a place we call 5 Ponds, because that's the first place where we dug 5 hand ponds to distribute water across the hillside. We actually used to harvest hay off on those fields, which don't look like fields anymore. Early on, probably in '96, I planted hybrid poplars all along the bottom side of this road. They were first logged off in 2011. They were used for building material for our cider mill building. They've been growing since, sprouting back from the stump. It was in 2001, fall of 2001, that this area here participated in a study with Southwest Badger Resource Conservation Development Council for direct seeding of hardwoods. And we planted approximately 3 bushel of black walnut per acre, just the seed, threw it out in the ground and drove it into the tractor, just drove over the top of it to see what it would do. We were the control plot, no herbicides, no weed control, no mowing, no anything. Let's just see what kind of stand we get. If we get 600 stems per acre after 3 years, then it qualifies as an acceptable practice in conservation reserve tree planting programs. The following spring, that would have been 2002, spring of 2002, we planted a whole bunch of white oak diagonally across this hillside, white oak alternating with traditional hybrid poplar, and then a whole bunch of Korean pine was also put in there in 2002. Probably 2004 or 2005, we planted a number of American chestnuts over here, pure American chestnuts we got from the West Coast. We've done nothing over there except for graze animals periodically. We hayed in the first 5 or 6 years, like I said, and then just let it all grow back to brush plus the trees that we planted. So this is the first entry into the site. If we look in the foreground here, we see a bunch of brush down by my feet. Yesterday I was out here for 1 chainsaw worth of gasoline, and in 1 chainsaw worth of gasoline I got a little bit less than a half a cord worth of firewood. This was some material that I cut last summer, and then some that I just cut yesterday. Those of you who remember the Christmas trees and the black locust stand, this clear spot over here was almost totally big with black locust. Cut it all down, pulled out a whole bunch of material for firewood, grazed the animals in there twice, cattle were in there twice this summer, and the Korean pine and balsam fir that were planted in there have now been released. They'll get more sun and they'll start to grow better. So what I'm doing in here today, I've got the chainsaw, 1 tank of gas. Look at that thicket in there. That thicket is not what I planted. I did not plant black locust. It's a wonderfully fabulous, incredible wood. Very high BTUs, a lot of heat in it. It's heavy, it's dense, it's hard, it's rock resistant, makes excellent scent posts and ground contact wood. However, it's got it's nitrogen fixing too. That's great for your grass. In theory, it'll help the trees. I've seen it affect the grass more than I've seen it affect the trees. And what I have had to do is destroy thousands of dollars with tractor tires. And right now, it's so fast growing that it's overtopped most of the walnuts, the oaks, and the chestnuts, and it's suppressing those species. So I want to favor the food-producing plants, chestnuts, the oaks, walnuts, etc., and higher value timber from the walnut. I'm going to remove a whole bunch, 99,000% of all the black locust in there, chop and
Chop and drop was what I was about to say. So this is, I hope everybody heard that. If you, if you heard that, a couple people can say it's fine, I heard it. This is a picture of what it looked like up close and personal before I dove in. And in the foreground here, you can see a couple of different willows as well. I also planted some FX67 hybrid willow that grows really, really fast. Okay, you heard it. Good, yay. It's getting pretty quiet here, and I'm wondering if I'm still on the air or not. So I went in there. What I did is, it's super easy. I'm going to cut down everything that's not what I want, not a crop tree. I want to favor my oaks. You can see some of these young oaks still surviving in there. I want to favor the black walnut. I want to favor the chestnuts. And what's interesting is we've been grazing in there for the past 20 years. Obviously, there's not a lot of grass left. And we used to cut hay in this particular spot, right exactly here. Let's go like that. There's some more of those little oaks. Here's the some hybrid poplars, and you can see how the stump is really fat. Once upon a time, we coppiced, cut down the hybrid poplars. They sprout up super vigorously. We took the lower logs, probably at least 8 foot off of every hybrid poplar was for saw logs, and we had it milled up into mostly for 2x4s, 2x6s for framing of our cider mill building. And then the smaller diameter material we inoculated with oyster mushrooms, and the oyster mushrooms flushed for a period of years, 3 to 5 years worth of oyster mushrooms. Then some of the taller stems we've gone and harvested some more again and inoculated with oyster mushrooms again. There's a nice little white oak in the foreground here. So what you'd see in here is I'd go in and I'd take out everything that's not a crop tree. I want to have more space for the trees that I favor, more light for the trees that I favor, more nutrients for the trees that I favor, and obviously when I cut down the locusts, they're going to release any of the nitrogen that they've sequestered in the soil, and that'll give a big flush of grass, hopefully help some of the trees to grow a little bit. And what will definitely happen is there's going to be a massive flush of black locust under here, and so this ought to be just a great place to graze the cattle next summer between the grass and the locust. The second chainsaw I went in, I started removing some more material. In the past, I've gone in there, I think it's 3 times, maybe 4 times now, probably 4 times. I've gone all the way through here, almost down to the limit of where you see the snow, all the way over to here. And I leave the brush right on the ground, choosing the spacing between the crop trees, the walnuts and chestnuts and oaks, of at least 8 feet so I can squeeze through with the tractor and use my flail chopper. So one of the things that I'll get is I'll get all of these wood chips will just be spread all over the ground, and that'll be good fertilizer, the ramial wood chip fertilizer, and I'll also inoculate that with Stropharia mushrooms. So this isn't much work. This right there, that picture right there, maybe represents a total of 2 hours worth of work. Another, just a picture of what an amazing mess thicket it is. And this one is a video again, and so I'm going to get it quiet again and see what I can do. I'm going to turn up the volume, maybe that'll help some. All right, here we go.
Well, it's easily been over a month since I've been at this spot before. This is black locust growing up over an area of direct seeded black walnut. There's chestnut, American chestnut in there. Also a hickory that I found. One of the hickories that came from seed from Calvin Kulik's front yard. I came out here last time with 1 tank full of chainsaw gas, ran it until it was all out, and I got about half a quart of firewood. The jug is about $150 worth of firewood. There's a little bit more locust firewood down in a pile right there. And so what I'm going to do today, I've got another, right after I did that last video, it snowed quite a bit, and then it rained on top of the snow, then it turned into ice, then it got real cold, and now it's finally warmed up a little bit, probably a month later. And so I'm just going to go in here and drop trees. I'm not going to cut log lengths out of it because life rears its lovely head, and you never know when you'll be back again. So I want to make sure that my hickories, chestnuts, and walnuts get the sun this summer, and they desperately need thinning right now. So down with the locusts. Bye-bye.
So one of the things on this, the thinning stage, the stem exclusion stage in this forest, this is right where it's at. And the ones that have been most competitive for resources is several walnuts that made it to the canopy, and they're going to do just fine whether I did the thinning or not. There's several oaks that made it to the canopy that'll do just fine whether I do the thinning or not. There are quite a few walnuts that did not make it to the canopy, and even more percentage-wise of white oaks that did not make it to the canopy. And right now they're underneath this particular thicket of trees. And as I got in there cutting, I realized that I really should have done this operation 3 years ago, because there's a lot of them that have died, and then many of them, they start looking for the light. That whole phototropism starts kicking in, and they just start sending a branch off somewhere looking for light. So I have a lot of trees that are now there all by themselves, but they're not as high quality, straight and tall for future value as can be. Now, if you think about how long that lesson I took to learn, that's a once in a lifetime lesson. I will never get to learn that lesson again. It took me 22 years to get to the point that says, oh shoot, I should have done this 3 years ago. So observationally, I know what this looks like now, and I can derive backwards by looking at the stem lengths and the different annual stem growth rings, and I can say, yeah, that when this was at this stage here, that tall, that's when I should have thinned it in order to favor the walnuts and the oaks. So if I go ahead and do this again somewhere, it'll be 20 years before I ever get to this stage. So now let's add that time up. That means I'll be 74 years old. But the quote-unquote mistake that I made, it's not a mistake, it's just feedback, it's what it is. I can't recover from that. So 22 years of my life, 22 years of site development, I went a little bit too far for most of those trees. Many of those trees are going to do just fine. So the ones that are now crooked and not the most supersonic, incredible trees, they'll just get thinned out at the next phase of the game. If you think about that, what we're doing, how we're interacting with our environment and growing crops, it's a lifetime worth of lessons, and the necessity of imparting information to one another and to next generations to learn from one another is so critical with this, because this was a once in a lifetime lesson. I could read about it 1,000 times, but to actually see what I'm looking at, to know what I'm looking at, and know when to act for the most amount of effect for the least amount of labor. It's taken me this long to learn it, and I'll never be able to do this again correctly. Here's some of the wood that I hauled out of it, quite a bit. There's a little bit of a faraway distance. You can see now how far apart these trees are. And what's really fascinating about this whole thing is all through these 22 years, we've been grazing cows out there. We've never stopped grazing cows out there. So we're estimating we're getting about 300 pounds of beef per acre out of this thing. And so we're still getting the original yield that we were originally getting, and we're getting additional yields on top of that. We're getting chestnuts, we're getting mushroom logs, we got saw logs that built a building. We're starting to get walnuts for seed that we can plant out elsewhere, we could eat. We're getting firewood, we're getting poles for building material. There's way more yield out of that system than just 300 pounds of beef. And it's a nice young forest. All these small diameter material, I'll pick this all up. This is outstanding firewood, and then I'll just be able to drive through here with the flail chopper and chip it all up, and that'll be a nice clean and green grassy understory beneath black walnut trees come the summer. Now, just to do a little bit of numbers, the previous owner was getting about 300 pounds of beef per acre. They weren't eating the beef. They were just buying them at the sale barn, a stalker cattle operation, buying at the sale barn in the spring, estimated price for $1 a pound, and then they'd sell it in the fall. So they make about $300 an acre on beef. on that particular piece of ground. Well, what we did at first is we got only $250 an acre at first because we did hay, and we split the hay yield with the neighbors. So for 2 different years, we got $250 per acre on hay, and then we still got our $300 an acre out of beef. And if we were to just do it at sale barn values, that's $300 of beef per year times 10 years. We did it, yeah, okay, 10 years. I said 97 at present, 10 years, $3,000 worth of beef. 2006 it was when we cut it, not 2011 like I said in the video. We got an estimated 980 board feet of milled hybrid poplar lumber, mostly as 2x4s for framing, and the bulk average return that you would get for 1,000 board feet would be like $330 per 1,000 board feet, and it comes from randomlengths.com. It has historical sawmill records for if I have a 1,000 board feet of lumber. That's what I would get paid for it. However, so that's $320 cash. If I had sold it, I didn't sell it. I built it into a building that then increased the appraised value of the property from $50,000. So I got $300 worth of lumber. Instead of selling it for cash, I took the $300 worth of lumber and made it into a building that was appraised at $50,000. I think that's a pretty good return on my investment. Of course, got around 300 pounds worth of oyster mushrooms for a $1,200 value, 3/4 firewood, about $450. So a total, using this set of numbers, not counting the $50,000, was $5,470 or $248 an acre per year. I got less than the original owner per acre per year because for a couple of years I only got half the yield because I split it on shares with somebody. So on average, really no different than the other guy. I'm still getting my 300 pounds of beef per year, and I'm getting all these other yields. That's, average farming. It's not that's not all that bad. Well, now if we do a little bit different calculation, let's say that I get the use value out of the beef. Instead of selling 300 pounds of beef for at the sale barn for crap prices, hey, let's say that I actually had to buy all of that beef that I ate, 300 pounds of beef per year at, say an average of $10 a pound, because some are going to be $18 to $20 cuts and some is going to be like $6 organic hamburger. I got $20,000 worth of beef off of that place in the past 20 years. That's a heck of a pile of cash. If I had to come up with that $20,000 to buy organic beef, I wouldn't be eating organic beef. I'm eating organic grass-fed beef because I'm raising it. It has an actual market value of $20,000 that I value. That's part of my return. And then my lumber, of course, $320, oyster mushrooms, $1,200. The beef and the mushrooms go good together. Comes out to a total, when you think about my use value of the beef, at $22,180 over the past 20 years, or $1,000 per acre per year. That's starting to look a heck of a lot better, ain't it? Well, then if we all of a sudden use the use value of the beef, I'm getting my $20,000 worth of beef out of that. Let's count my appraised value increase by building the building, $50,000, because that was real. I took $320 worth of material and some other stuff, and I turned it into a $50,000 building. That's a real gain. That's a real value that was produced by me growing this type of agriculture instead of just growing corn or just raising beef. The guy who was just raising beef there forever, he could do that for 20 years. He's making $300 an acre a year. He doesn't have enough wood to make a building out of it, and then he doesn't have the value of the building. If he sells it, then he gets $50,000. If I refinance on that, which I have, I've refinanced on the appraised value of that building in order to go build something else. So I genuinely have got over $3,000 an acre dollar value returned to me. What's important about this, did I get the value, most of the value from the agricultural production? Not necessarily. Selling the beef, selling the mushrooms, I guess, and selling the wood would be considered the agricultural value of that. I get the use value for the beef and the equity value from the building that I built out of it. One of the things that I didn't even do was to throw in the change in value of the land. Regular farmland, grazing land around here goes for around $3,000 an acre. Prime recreational land that has trees all over it, you know, some timber on it, there's good wildlife habitat, will go for around $5,000 an acre. An additional gain that I've gotten by farming this way was with the increased real estate value. I didn't even put that on this particular chart. Part of what I'm trying to point out here is this type of agriculture requires very little input. I have experienced zero decrease in yields over the prior land use. I have converted it from a purely grazing operation into this totally mixed use operation, and I have had zero decline in my ability to raise beef on the property. As a matter of fact, I probably could start to get better beef because the grass that's growing underneath those hybrid poplars is insane. Plus the animals can now browse on the trees. I have more feed for animals, and I have trees, and I have mushrooms, and I have the ability to make buildings, and I have firewood, and this type of agriculture reduces your expenses down to almost nothing, a little bit of work, and your yields are for asset development are through the roof. How can I handle this? This is too much. Help! There's Karen helping us again. Imitate your natural plant communities. When you imitate the natural plant communities of the area, you have the highest chance of success. Nature has been succeeding on your site forever. Agriculture has only been there for a few calendar minutes in geological time. Strategically disturb the site. Try to imitate what would happen with catastrophic, wind throw or forest, big fire that would come through, trampling, grazing. Then establish your closely mimicked plant community. We can make substitutions. We can substitute improved cultivars. Like in the case of pine, I'll substitute Korean pine for white pine, both a 5-needle pine, virtually identical to one another. One's not a native. I don't care. It's producing food and timber and wildlife habitat. The soybean is not a native. It's not even a native to this continent at all. It belongs over in Southeast Asia. Send it back. Let's start roundupping zillions of acres of soybeans because it's invading our prairies and our forests. Manage your water resource, of course. Episodically disturb the site. That's all I did up above the previous little videos there. I'm disturbing it much like a firewood. It would go through. There'd be like a blowdown. These trees would fall down, and then the biomass gets consumed and it goes away. So it's kind of like a fire and a blowdown combined. And then, of course, we'll disturb with herbivory. We'll send the cows in this spring. And we disturb the site by harvesting yields. Instead of spending money on a pre-commercial thinning that is nothing but an expense for us, let's get our management done by harvesting a yield for us. And to get a food yield is a real yield, even if it doesn't convert into dollars. And we want to keep that system within our most productive successional phase in order to meet our objectives. You might want a closed canopy forest that goes fully shade and just, stays that way for another 1,000 years. Or you might want to keep it in that savanna, brushy savanna phase with grass and livestock and so on. Our food and livelihood can now come from interacting with a genuine natural community, and hopefully we're an intelligent and informed disturbance. We'll harvest multiple yields through the season, from early spring plants such as raspberries and currants to late fall things such as grapes and acorns, chestnuts and hazelnuts and apples. We're harvesting mushrooms in the decay cycle, and it looks beautiful. I think it looks beautiful. And when I'm going in California, this is the kind of agriculture I want to be leaving behind when I walk through California. So still to come in the weeks ahead. We're going to do mostly root structure and growth of woody plants. Then we'll do nutrient cycling. Maybe we'll combine the nutrient cycling and carbon cycling together. And then just do a little brief overview of the major forest types of the world. And we'll start to review some of your work. All right. That's all I have for the main portion of this evening. We'll take a couple of questions, and then we can go ahead and take off. I do see a
Mark, if you
question. Go ahead.
If you can see them, I'm going to just mute myself again so that feedback doesn't come back.
Okay, I'm going to start at the bottom. I saw Mary Combs' comment about, is Korean pine resistant to white pine blister rust? I don't know if it's resistant to white pine blister rust, but one of the things about blister rust is white pine blister rust is not what destroyed white pine in Idaho. What destroyed white pine in Idaho was over-aggressive clear cutting and hammering of the ecotypes so bad that the ones that remained were really, really suffering. And then a natural, native, naturally occurring disease went in and finished off a few of the other ones. And then as a response to some of the disease catching the pines, it's like, oh my goodness, the pines are getting white pine blister rust. We better cut the other ones down so they don't get it too. So I know of no disease in forestry yet that has destroyed a forest resource, except that it has been exacerbated by human beings. And chestnut blight is the perfect example. Our response to chestnut blight as a human species was to short circuit the natural mechanism by which chestnut would develop resistance to blight, and it was done as a political maneuver by the timber companies that wanted to cut down that huge resource. So is Korean pine resistant to blister rust? I don't think so, and it's really don't think it's not that much of an issue. In the grove where I left trees 3 years too long, why would coppicing the bendy trees be a way? Would coppicing the bendy trees be a way to recover them? Some of the bendy trees are black walnut, for example. They're the ones that started to get real bendy, and they don't coppice all that well once they've reached a certain age. When they're really young, you can clip them off close to the ground, and they've got a little bud down there, and they'll sprout back up. But as they get older, they don't respond to coppicing as well. You just cut them, and they're dead. And so I'll let the bendy ones grow, and I'll use them later on for firewood or whatnot. How long do the thorns and black locusts persist once you chop them down? I do believe forever. I'm not quite sure. I really hope they aren't as rot resistant as the wood is. It was quite rot resistant. Let's see, another question. Coppicing. What about pruning? Well, let's see. This is a response to Ray's question. I prefer to do the coppicing because it's a heck of a lot faster. In pruning, you have to select individual branches and kind of be thinking about which way they're going to grow, knowing how the tree responds to it. Make sure you don't take too much and all that stuff. I would rather, like in the case of hazelnut, I just drive over them with my flail chopper and I just chip them all up and I start over. Raspberry is a great example. I was just at a place in Ontario a couple days ago, and they were putting up these trellis wires for raspberries on their ever-bearing raspberries. And what's interesting about ever-bearing raspberries is they'll send up a primocane first, primary growth, and then they immediately send out their secondary growth that has the fruit on it. So the primocane grows in the spring, and then the secondary growth is through the summer, and then it has berries in the fall. Well, meanwhile, there's other primocanes that grow up and that are there in the fall that will have berries next spring. So if you have ever-bearing raspberries and you know their growth behavior, you plant 2 rows of ever-bearing raspberries, and instead of going through and pruning out the third, 1/3 of the oldest material, putting in a pole, holding it between wires, it's like, F that. Have 2 rows of ever-bearing raspberries, mow one in the spring this year, mow the next one in the spring next year, and you'll always have raspberries instead of pruning. Instead of going through branch by branch by branch by branch, I go through 7 miles an hour, just chip them all up and it's over with. So yeah, you can prune trees. It's fine, but I would rather not. I got 100 acres. Instead of have 100,000 people out there, I'll just take care of my trees differently. And albida. I'm actually answering a question for Fernando. Phyderbia albida is an acacia, and I'm going to send it to everybody because he wanted it spelled. And let's see, why don't I take another question? Let's see, who's got one? Echo's gone, no more echoes. Doom-da-dum. All right. All right, who's got a question? Cool. You guys must be asleep tonight. All right. What's going to be happening at the workshop in New York? This will be what I'll talk about right now, and then we'll call it after this. Workshop in Stephentown, New York. We've already had an initial site consultation. We got a basic layout idea that we're going to now go out and survey and mark in the ground. So I believe we'll be starting on a Friday afternoon evening. It will be like an introduction to the overall concept and principles that we're playing with on that particular site. Then it will be the next day, Saturday, we'll talk exclusively about water management in the morning, and we will begin to lay out the water management design on the property. And at some point in time, hopefully Saturday, will be when Eric Berg, my dozer operator engineer guy, shows up, and he'll begin installing it. And so it's a small site when it comes to bulldozer work. Probably only take 3 or 4 days. Everybody is welcome to stay as long as they want to watch the project as it unfolds. And Eric will be there till it's finished, obviously. By Sunday afternoon, it's going to be roughed in really easy. Maybe there'll be 1 or 2 elements of it that'll be finished up real good. So it's going to be a waterworks design and build installation. Stephentown, New York, and Wayne is going to, or already has, put the link to it up on the website. And those of you who are interested or out of California, come on out. I think it's going to be in Santa Rosa or Santa Barbara, which one of those, I'm not quite sure. I'm just going to get on the plane and see who picks me up. All right, thank you, everybody, for being here tonight. And we will talk to you next week. Good night, guys.